Okay. All right. Today, we are going to do a quick run through of some practices for probability. So, your worksheet is available on Google Classroom. So, let's go through the questions for probability. Okay. First question over here. A bag contains 50 equally sized marbles. 18 are green. X are yellow and the rest are red. So usually for me, I have a habit of writing down 18 green, X yellow, then the rest are red. So the rest are red in January means I don't know how many, but some number are red. Okay, and I know the total is going to be 50. They say 50 equally sized. So if a marble is selected randomly from the bag, find the probability that the marble selected is a green marble. So if I want a green marble, I take the number of green, which is 18, out of, oops, sorry. Okay, 18 out of a total of 50. So it's 18 over 50. Right? But we simplify the fraction 18 over 50, a total 9 over 25. Okay. Next one, find the probability that the marble selected is not a green marble. Not, right? So this is actually 1 minus probability of selecting a green marble, right? So 1 minus this, so you get all the other possibilities. So I just take the answer 1 minus 9 over 25, and that will give me my answer 16 over 25. Is this okay so far? Okay. Next question. If the probability of selecting a yellow marble is 3 over 10, find the value of x. What is the x value? I have a yellow marble. That means I want the number of yellow. There are x yellow marble. Out of a total of 50, they gave me that this probability is equals to 3 out of 10. So making this the same denominator, I'll times 5. So that means x over 50 is equals to 15 over 50. And I can see therefore x equals to 15, the answer. Alternatively, you can also cross multiply to find the value for x. Okay. Next question, how many marbles are there in the bag that is red in color? So I have a total of 50 minus away 18 green, and I found 15 to be yellow. So number of red will be this answer. And I get the answer of 17 red marbles. Okay. Is it okay? Are you okay with this part of the question? Hello? You okay not with this part of the question? Okay, okay, no response. One hand up means okay. Right. Question number 2. A bag A contains some colored cards, while bag B contains some colored discs. Give me a minute, huh? Okay, so what do we notice over here? Bag A is colored cards. Bag B is a disc. All right. And you notice that in bag A itself, observe there is red, red, yellow, yellow, green, blue. What does this mean? This means I have actually 2 red colors, 2 yellow, 1 green, 1 blue cards. All right. Compared to this itself, look at the bag B. You only have red, orange, yellow, green. So there are only 1 occurrence for each one. So that means it will be just 1 of each of the different color. Okay. In this possibility diagram below, write down the possible colors of the card and the disc. Okay. So what we need to know, we need to identify what is the order first. I pick is it from bag A and bag B, or what is it? So I look at this example over here. Notice this is green and they put G, comma, R, meaning in this column, they choose green, then they choose the red, this. So it's a green cut, then a red this. So if I were to fill in for the others similarly, over here, this one at this portion, I will follow a yellow followed by red. So this one will be yellow, comma, red. And the next one will also be yellow, red again. Last one, blue, red. Okay, so similarly, are you able to tell me what will be the ones over here? This one will be red, orange, green, orange. So we can use this to fill up our table, yellow, 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 blue. And this one is red, green, green, green. Okay, so we have a total of all these combinations. So first things, what we usually need to do, we need to count how many possible outcomes are there here in total. Notice that there's no squares or what do you call that? There's no columns or boxes that is actually black. Okay, if the boxes is being colored black, it means that the case cannot happen. So in this case, since everything have a combination, there's a total of 1, 2, 3, 4, 5, 6. So 6 column, 6 by 1, 2, 3, 4, 6 by 4. So there will be a total of 24 possible outcomes. Okay, so when we use a possibility diagram, you have all the different possible outcomes ready. We're going to count the number of outcomes, okay, that they want. Find the probability that both the cut and the disc have the same color. So if I want the cut and the disc to have the same color, so I'm going to choose the one same color. That would be red, 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 red. Any more? Yellow, 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 yellow. There isn't orange, orange, right? And then we have green, green. Okay. And out of these, how many cases do we have? 1, 2, 3, 4, 5. We have 5 cases. 5 cases. 5 cases out of a total of 24. So this one, the probability that the cut and the disc have same color, 5 cases out of 24. Okay, are you okay with this so far? Now manage to fill out the possibility diagram. Okay, thank you. Okay, at least one of the item is yellow. At least one of the item is yellow, meaning I must have a yellow color somewhere. Okay, at least one of the color item is yellow. Let me highlight in another different color. 1 case, 2, anyone that is yellow, they didn't fix the position, right? 3, 4. Then this one, everything here also have yellow, 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 yellow. Okay, so in total, let's calculate the number of cases. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's a total of 12 cases out of a total of 24 cases. But I must remember to simplify. That will give you half. Okay. Next question. None of the items are red or yellow. So I don't want red. I don't want yellow color. So the only one that I can choose probably will be, okay, maybe I choose a blue in this case. Now, no red. So no red, no yellow, oh, no red, this one. No red, no red. 1, 2. No red, no red. No yellow. Oh, green, green. Blue, green. And any more? Okay, so in this case, I counted 4 cases. Are there any more other cases? No, right? So it should be this one. So it'll be 4 out of 24. Then we simplify these and we get the number 1/6. Is this okay so far? Okay, then next question. Okay, this question over here, this one you notice, I drew the table over here for you to list down the different cases. If you look at our TYS, the more common one is there will be a spinner or there's some other things that they ask you to choose. All right. Now notice that a purse contains 10 cent coin, 20 cent coin, 50 cent, and a $1. Okay, 2 coins are taken out from the purse. Notice that there is only one of each. So I cannot have a case of 10 cent, 10 cent. I also cannot have 20 cent, 20 cent, 50 cent, 50 cent, and $1, $1. So I only can have a combination of different coins. All right. So the first coin, if I choose a 10 cent, then 10 cent can match with a 20 cent, match with a 50 cent, or the third combination, 10 cent with a $1 coin. Okay, so that's the first combination. Hello. Okay, thank you. Okay. Next question. Next part. So after I pick my 10 cent already, 10 cent can match with 20 cent, 50 cent, $1 coin. The next combination is I'm going to choose my 20 cent first. So I choose my 20 cent. Now I use my 20 cent already, right? 20 cent can match with a 10 cent coin. Then match with a 20 cent, match with another 50 cent coin. Then 20 cent match with a $1 coin. Okay, so next combination, after I choose my 20 cent, I can start off with 50 cent. 50 cent can choose a 10 cent coin. 50 cent with a 20 cent coin. 50 cent with a $1 coin. Okay, alamak, I got not enough space. Okay, I think my handwriting is too big. Okay, let me shift this up a little bit. Okay, not enough space really. Then last one, $1 coin. I can choose my $1 coin first. So I choose a $1 coin. $1 coin followed by a 10 cent coin. $1 coin followed by a $1 coin followed by a 10 cent. I write on the other side, okay? Then $1 followed by a 20 cent. And $1 followed by a 50 cent coin. Okay, so these are all the different combinations that I can find. So they listed out 2 possible outcomes. I complete all the possible remaining outcomes. Then the next thing is we're going to count the number of outcomes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's a total of 12 possible outcomes. Okay, so if I'm going to use this later to find the probability, my denominator will start with 12. Question here say hands up. So that means I must use the cases that I have listed out over here to help me count my answer. Find the probability that the total amount of 2 coins is more than 20 cents. Now observe, what is the smallest possible case, the cheapest, not say cheapest, the smallest value. The smallest value is actually 10 cent, 20 cent, right? 10 cent, 20 cent. So the smallest value that you can get for the total is 30 cents. They say they want something more than 20 cents. It is a confirm, it is sure, it is 100% confirmed that any two coins that I pick will definitely be more than 20 cents. So hence, the maximum probability for the answer will be 1. Okay, 1 means this is a sure event. It confirm will happen. Okay, must be. All right. Well, alternatively, the one like the opposite, the zero, zero means it's an impossible event. Okay. Now, question say at least $1. What are the cases that we can have for it to be at least $1? $1 or more. That means I must at least pick a $1 coin, right? I have one case over here, at least $1 coin, $1 coin, $1, $1, $1. Okay, let's check. Do we have any other combinations that can give me maybe 50 cent? Oh, but I don't have 50 cent plus another 50 cent, so cannot have $1. Okay, so these are all my cases. I have 1, 2, 3, 4, 5, 6. 6 out of a total of 12 possible cases. So this probability will be 6 over 12. Simplify 1 over 2. Next, I want the case of less than 50 cent. Less than 50 cent. What are the cases that is less than 50 cent? First case, 10 cent, 20 cent. 1. 10 cent, 50 cent, no, exceed already. They want less than 50 cent, right? 10 cent, 20 cent. 2. No anymore. Okay, don't have already. So the rest are more than 50 cents. So this is only 2 cases. So that will be 2 out of a total of 12. Simplifying your answer, 1 over 6. Have you gotten the concept? Okay, Can, then I continue. Okay, question number 4. This one got a lot of cases. I need to go through this a little bit slower. Okay, Donovan bought 10 pens from a stationery shop. So I start off with 10 pens. First possible case, 6 of the pen are blue. So there are, to start off, 6 are blue. The remaining pens are red, meaning there are total of 10 pens, meaning there will be 4 of them that is red. Total is 10. If the total is 10, and when I choose my first pen, I will have 10 pens to choose from. Okay? Then, what's the probability of choosing a blue? Probability of choosing a blue, there are 6 of them. So it's 6 and 4 red, 4 over 10. Notice for a probability diagram, tree diagram itself, in the tree diagram, the numbers inside the boxes here may not be simplified for, because it's to show you how many actual numbers are there rather than the simplified version. But if they have an answer blank that they ask you to fill in, the answer over here needs to be the simplified answer. Okay, but for a tree diagram itself, the answer in the box can choose to remain as 4 over 10, no need to simplify. Is this okay? All right. Next part. Now, assuming that my first case, let's say I took out my blue already. I already take out 1 blue. How many blue do I have now? After I choose my first pen, I'm going to look my second pen. After I take out 1 blue color, okay, after I take out 1 blue color, I'm left with only 5 blue and a total of 4 red. And that will give me a total of 9 pens. What does that tells me? That tells me the denominator over here will now change to 9. Will now change to 9. How many blue are there? 5 blue. How many red are there? 4 red. Okay, so this is the second scenario over here. Any questions for this portion? Okay, no response. Okay, I assume do not sure you let me know again, then I explain again. Okay, now so the first case, this is assuming I took out a blue color, right? Now we are going to work for my second branch, assuming now I never take out the blue color. Instead, I take out only the red color. Originally, I had 6 blue. I did not take out any blue color, right? So it remains as 6 blue. I started off with 4 red color, but I pick out 1 red color in this case over here. After taking out 1 red from 4, it changes to 3 red. How many do I have in total? How many do I have in total? Nobody asked my question. 9. All right. What does this mean? This tells me that the denominator over here is 9. The denominator over here is also the number 9. I have 6 blue and there will be 3 red. Okay, so this one is going to be the answer for the tree diagram itself. So I'll put this down below, considering the case. I'll shift this to this side. Okay, so what is going to be the outcomes? Personally, I always label all the different outcomes. So my outcome over here, okay, this one I cannot list the outcomes and count the probability just from the number, because the probability on each of the branches have to be multiplied together. This case over here is a blue, 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 red, red, blue, and red, red. Okay, so these are my combinations. First question says, find the probability that the first pen is blue and the second pen is red. So they want a blue and then followed by a red. In probability, N means, what does N means? What do we do to the probability when we have the word N?
Is it plus
No, the other one.
or times?
Yes. Then when do we plus?
Or
Yeah, correct. Or means you add. Okay, so in this case, blue and then red. So this one means this is a multiplication. Let's take a look at the branches. Blue and then red. Thank you for trying. At least you answer me, then I'll know what you understand, right? So blue and then followed by red color. What's the probability on the blue branch?
6 times 4
Before you do 6 times 4, what's the, yes, 6 times 4, but what is the fraction? 6 over what?
or 6/10.
Correct. Very good. 6 over 10. Then the next one, the branch for the red one.
4/9.
Very good. Okay. And they say first pen is blue, second pen is red. So there's only one such combination. So let me calculate my answer. 4 over 9. Answer will be 4 over 15. Only one possible case. Okay? Can? Let's try the next question. 2 pens are of different colors. Different colors. Different colors. What are the different colors, possible combinations that I can have? There are many combinations, right? First case, I can have a blue and then a red. I'll change the word and into comma because they are together, and red. Or can you tell me another possible case?
Red and blue.
Thank you. Red and then blue. So we have the word and means we need to multiply, or there's a different case, so different cases, so we add. Okay, the next probability, multiply. Right? Let's try. I want blue followed by red. Doesn't this look familiar? We already have the combination just now. Blue followed by red. Okay, so I will follow this. Blue 6/10 times red 4/9. Or the case, or means we are doing addition or plus. Can you tell me what is the probability for the second case? I want red followed by blue. Red followed by blue. What will I put inside my bracket? Red followed by blue.
6/9.
The blue is a 6/9, correct? Then what about the red one?
4/10.
Correct. Good. Then we work out this number, add the two cases together. 6/10 times 4/9. Okay, plus 4/10 times 6/9. Answer 8/15. Okay, next question. At least one of the pens is blue. At least one of the pen is blue. When we see this kind of question and the word at least, we should usually try to think of a opposite way. Okay, so the normal case is I'm going to list down, oh, I want blue, 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 red, red, blue. But I need to calculate three cases, actually very long. So what is the shortcut to do this? When they say at least, means I'm going to take 1 minus away the probability of the case that I do not want it to happen, which is the case that I don't want. The case that I don't want is red, red, because I want at least one of them to be blue color, right? So I'll do the short version. 1 minus away, take away the case where it's red and red. Red and red, or red comma red also can. So I just write the word and for you to see. All right. So in this case, the shorter method will be 1 minus probability of red and red. So n means multiplication. Now we want the case where it's red and red. What is the probability that we put inside? Who is in our Zoom today also? Elise, are you there? Or Elise fall asleep already? Elise?
Yeah.
Yeah, okay. Can you tell me how to find red, red?
Uh,
Huh? 4 what?
4/10.
4/10 multiply by
3/9.
3/what?
9.
9. Correct. Then we get this case, the answer 1 minus 4/10 times 3/9. Answer 13/15. Is this okay? Any question for this part? Any questions for this part? No questions? Then I'm going to move on to the next question already. Next question. Confirm? All right. Okay, next question. Question number 5. Angel either walks or cycle to school every morning. The probability that she walk is, my is disappeared, 2/3. And the probability that she walks, when she walk, the probability that she's late for school is 4/9. Oh, what is this question talking about? When she cycles, the probability that she's late for school is 1/9. So in this case, first part of the sentence, let me begin with the first part. Angel either walks or cycle to school. So we have a first thing to choose, whether does she walk or does she cycle to school. So our first option is to see and think, oh, I walk to school, or I cycle. This is how she go to school, right? So the probability that of her walking is 2/3. The question gives the probability of her walking is 2/3. But then we need to think at the same time, if she either walks or she cycle. The probability here and the probability of walking and cycling both must add up to 1. If they add together, the total probability must be 1 whole. So if she's walking, it's 2/3 of a chance. What's the probability that she is going to cycle to school? What's the probability that she's going to cycle to school? The two, I repeat again, the two of them, this probability and the probability over here must add up to 1 whole. Anyone can tell me how to find the answer over here? What is the probability of her cycling to school?
Is it 1 minus 2 out of 3?
Correct. Very good. Thank you very much. So for her to cycle to school, 1 minus 2/3, that will give you the answer 1/3. This is very important. Must understand the concept. Okay, so everything add up to a total of 1 whole. This one will be 1/3. 1 minus 2/3. Well done. Okay, now let us analyze the next sentence. The next sentence say when she walk. So if she walk, then next, the probability that she is late or she is not late. So either late or if not, you're on time, right? So the probability of her, the second portion, what does the sentence actually means? It means probability of being late is 4/9. If that is the case, if she walk and she is late, what is the probability of her being not late? The probability when she walks, the probability that she is late is 4/9. What will be the probability when she walks and she is not late? Again, this number over here, this probability and the probability over here must add up to 1. Okay, anyone can help to tell me what is the answer over here in this box?
5/9.
Thank you. 5/9. How do we get this answer? We take 1 whole minus 4/9. Okay, we take 1 whole minus 4/9. Can? Then similarly, next statement. When she cycles, if she cycles, the probability that she is late for school is 1/9. The probability of her being late is 1/9. Then what does this tells me? This tells me the other branch is not late. What will be the probability of cycling but not late?
8/9.
Thank you. Okay, correct. So find the probability on a particular morning, Angel walk and not late for school. Probability that Angel walks and not late for school. Walk and not late. What does the word and means?
2 out of 3 times 5 out of 9.
Correct. Very good. So walking, 2 out of 3. And not late means multiply. Not late, 5 over 9. Answer 2 over 3. 10 over 27. Okay. Next, what is the probability that she is late? What are the cases that we can have for her being late? Is there only one particular case, or there is actually more than one case? What are the cases? Let's take a look. I want her being late, right? Late. So this case, how to get this case? This case is walk and then late. So my first case, I walk and then I am late. Or is there another case that can actually be true so that she's late?
Cycle and late.
Correct. Cycle and then late. Again, and means we multiply. What does all means?
Plus.
Plus. Very good. So walk and late. How can I fill up the answer? Walk and then late. So what would be the numbers inside my brackets over here? Walk.
Can we just take 10 out of 27?
10 over 27 is walk and not late.
Oh.
Not same, Sometimes can use, sometimes must see whether same or not the same. So this one should be what? The correct idea, 2/3 times which one?
4 out of 9.
Correct. Right? Then what about the second case? Cycle and then late.
1/3 and 1 of 9.
Correct. Good. Then we calculate the answer for this. I got answer 1/3. Do y'all get the same answer? Okay. So we know the cases already. So these are the cases. So this is actually not an easy question because there's a lot of interpretation and understanding to fill up the boxes. And not only that, you need to know how you want to draw this whatever possibility tree diagram over here. Okay, so this is actually quite a high level question, quite difficult. So you need to think a little bit. Okay. Next question. I'm going to move on already. Next question. Now, why am I doing this question? I skip some of the parts. Actually, this question itself, the probability in section B, paper 2, section B, probability is usually always linked together with the frequency diagram, the cumulative frequency diagram. So if you want to learn this kind of questions on top here, these are usually in paper 1 or in the first few parts. Okay, but in paper 2, if you have questions on probability, it will usually always be the one at the back in section B itself. Okay, so now I just revise a little bit of skills, okay, for you to find the cumulative frequency curve and how does it link to a group table. The normal portions of a question will start with finding the median, interquartile range, and then reading certain numbers. But if I were to link it to probability, sometimes they can ask us to fill up the frequency table. So I choose to have the table of everything blank so that I can go through with you in detail how to find the answers. First part, the question is here says, marks is on this axis, number of marks. Notice this is the number of marks. So 0 to 5 marks. less than equals to 5. And this is my frequency. A normal one that students always check, students always assume the highest number is going to be a total frequency. This is not true. Read the question. The cumulative frequency below shows 72 students, meaning this number over here then is my final, my total number. So the maximum actually is at 72. I purposely picked this question because a lot of students will assume 80 is the 100% is the total. No, it is actually given in the question. So please read the question carefully. Okay, then next they want marks between 0 to 5. Between 0 to 5, are there any students or not? There aren't anything. So less than equals to 5, the frequency is 0. Next, from the interval 5 to 10, between 5 to 10 marks. Okay, between 5 to 10 marks. Between 5 to 10 marks, 5 was 0, but the one at 10 marks over here, this number, okay, is somewhere in the middle. We need to estimate it a little bit. So 1, 2, 3, 4, 5. 5 squares represent 10 units. 1 square represent 2 units. So this is 0.5 over squared, 1, 2, 3. This will be the number 7. Then my 5, and when it's at 5, the number is 0. So this is actually 7 minus 0, which gives you the number 7. Okay. Who else is here? Did I omit the person? Okay. Okay. So this is the number 7 minus 0. Why do I say that? My number over here, there's a total of from 0 to 10, there is 7 students. But 0 to 5, there is 0 students. So I need to find in between, right? I need to minus away. So this answer will be 7. Next one, I'm looking at the number between 10 to 15. I only want the number in between 10 to 15. So I'm going to draw 15, the number at 15. This number over here will be 10. 1 square, 2 units, 12, 14, 16, 18. So this number over here is 18. But remember, I only want the portion between 10 to 15. So I want between 18 and 7. So I'm going to take 18 minus 7 to give me the answer 11. Have you gotten the concept? Are you okay with this portion?
Yes.
So we are we are looking at the in between, right? So we need to minus away. So I just do a few more, I'll continue. 15 to 20. 15 to 20. Now they change. They want 15 to 20. Right? 15 to 20. What is the number for my 20? Can you read for me? Is it in the middle or it exceeds a little bit? Is it in the middle? No, right? It's in the middle,
No.
right? Is it I don't know. What number is this?
32,
32
I think.
No leh, I think it look like it exceeds a little bit. Wait. Got final answer one. Let me see the final. Let me see my answer key. 7, 11. This one they say is 14. 14. Okay, let's try. Is it 32 or is it 33? 14 plus 18. 32. Okay, so you are correct. 32. Okay, 32. Okay. So if this number is 32, then this one here will be 32 minus my number over here. This one 32, between 32 and 18, right? So 32 minus 18 equals to a number 14. Okay, so now you all know the concept already, right? How to find the different numbers. I should save a little bit of time. I kept the answers 22, 10, 6, and 2. We should just use this directly, okay? 22, 10, 6, 2, according to the answer key. Then if you want further practice, you can find the answers on your own later, okay? So this is the concept. So now we know the frequency table. Now, after we know the frequency table already, I want to find the probability. When you talk about probability, I always find the first thing, what is the total number of students? Our total number of students is, it's not 80, it is the number 72. So the total number of students is actually 72, not 80, okay? Not 80. So that means whatever I have, my total denominator will start with the number 72. 2 students are chosen at random. You need to have 2 different students, correct? Not, you cannot have them to be exactly the same. So you notice that when I first started off, I will have 72 students to choose from. After I take out 1 student, and then I want to choose the second student again, what will happen to the denominator? What will happen to the denominator? What will I get? Originally, it's 72 students. I pick up 1 student. What will be the denominator now?
71.
Thank you. It decreases for 71. Okay, so this is the very first thing I need to know. I haven't even read the question fully, but I know it have to be like that. Okay, let's start with the question. Find the probability that both students get something. They want this category above 15, less than or equal to 25. Meaning, I want between 15 and 25. I want in between 15 and 25. Where is the 15 and 25? Oh, I got 15, 20, 20, 25. So how many students are there that fits this category above 15, less than equals to 25? How many students are there in total? There are 14 plus 22, 36 students in total. Okay, 36 students in total. So what is my combination? I want both of them to be like that, right? So both of them, I have to choose from these 38 students. So when I pick my first student, I have 36 of them who satisfy this category. It's 36. But after I pick out 1 student from here, I pick out 1. Now I want to pick the second student again. How many such students satisfy this category? From 36, I took out 1 student. They are the people that meets my category. I take out 1. How many students am I left with now that satisfy this 15 to 25?
35.
Correct. Then I work out this combination. This is my answer. Answer will be 35 over 142. Okay. Are you okay with this concept? Anyone got any questions that you need to ask me? Okay with this? Okay or not? Can I continue already? Yeah? Okay, so this is usually the last part of the question. Okay, one part of the question. I do one more something similar. Okay, the cumulative frequency curve over here, all right, shows the members of a Zumba club. Again, I purposely picked this question. The axis looks like the total is 25. Is the total really 25? Observe, look at the total. What is the total number? Is it really 25? No, the total is how many? We are count the number of units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 square represent 5 unit. 10 square equals to 5 unit. 1 square you divide by 10. 5 divided by 10, 0.5 of a unit. So in this case, 21 is 2 square. 22, 23, 24. There is a total of 24 students. Okay, the total is 24 students. I hope you are still awake. Now notice over here, this cumulative frequency curve is very ugly. It's not very smooth, but it just means that this one may be a practical situation in real life. There are not numbers that are very nice. Okay, so it still can be done. And then they say this is the result, the data collected for all the mass. So this unit over here is the kg, right? Kilograms. Okay. The members of the Zumba club are selected at random. I have a couple of cases. Find the probability that only one member, okay, I choose one person only. So if I only choose one person, what will be the denominator total number of students I can have to choose from? The total number of not students are members. The total number of members that I can choose from is 24. So I need to start off with the denominator. This one will be over 24. Out of 24 members. But then this criteria says they want less than 55 kg. What is less than 55 kg? 55. So I read number 55. Less than 55 kg means from 0 to 55. Meaning I want 0 to 55. Okay, 0 to 55. Let's count this number. 5, 6, 7, 8, 9. 9%. From 0 to 55, 0 to 9. So there are 9 people, 9 members in total that fits this category. Then we check 9 over 24, simplify 3 over 8. Do you understand this part of the question? Okay, No question, nobody say anything, so I assume you know, okay? Next question. 2 members are chosen. 2 members are chosen. That means when I first started off, there is a total of 24 members. And then I'm going to choose one more member. After I take out one member, what is going to be the denominator over here? After I take out one member, what's going to be the denominator over here?
23.
Thank you. Okay, now let's take a look. What do they want? They want one is more than 65 kg. More than 65 kg. The other will be less than or equal to 50 kg. Okay, let's observe slowly. More than 65. Where are the people that is more than 65? Oh, 65 is here. Question, more than 65. Do I want 0 to 65? Or do I want 65 to 75? Which category do I want? More
65
than
to 75.
correct. So I want the portion that is 65 to 75. What does this mean? Means I need to read the number for these two ends. So I need to read 65. Oh, this is a very long line. How am I going to draw this? Okay. And I need the 175. The 75, I already know this one is 24. This one is the number. What is this number? 21, 22, right? So this number is 22, meaning they want the portion between 65 to 75, right? So they only want this portion. So between 65 to 25, 65 to 75, there are only 24 minus 22. 24 minus 22. There are only two students, two members who satisfy this category. Let's look at the next category. The other will be less than or equal to 50 kg. Less than or equal to 50 kg. Less than or equal 50 kg. Do they want 0 to 50 or they want 50 to 75? Which one do they want?
0 to 50.
Correct. So 0 to 50 is 0, very happy, and this is already 0. Let's look at the one with 50. This number will be 6 units. So the number over here, 0 to 6, there will be 6 people in this category. Okay, 6 of them who satisfy this category. Right? First part, you understand how we get the numbers already? Second part, let's consider the number of cases. They only tell me that one is heavy, the other one is light. Did they say which one must come first? Did they pick which one must be first?
No.
They want the heavy one first or the light first? No, right? They never say so, right? So what are the different possible cases? I can have the case of choosing the heavier one, the one that's more than 65 kg. And then I choose the one that is the lighter one, less than or equal to 50 kg. Okay, I lazy to write in English, so I put in quotation symbol. So if that's the case, this is the first case. All right, this is the heavy and then the light one. Or I can have another case. What is the second combination that I can have? Anyone tell me?
Less than 50 and more than 65.
Correct. And more than 65 kg. Okay, now we have these two combinations. Let us start with the numbers. More than 65. How many of them satisfy this category? More than 65. There are 2 students. And not 2 students, 2 members. All right. And then n, so we multiply. Next one, less than 50. How many of them in this category? Less than 50? 6 of them. Or I'm going to add. What is the next combination? Again, I'm going to choose 2 members. The first denominator will be a total of how many students?
24.
And then after I take out 1 student, my denominator will be
23.
23. Elise, are you still awake, Elise?
Yeah.
Okay, very good. Because you told me you sleep, so I must call you. Then I call the other person. Lynn, are you still there?
Yes.
Okay. Anyone can tell me what number do I start off with now? I want the less than 50 kg. How many?
2.
Okay, quiet. Less than 50 kg. Look very careful. Look clearly. Where's the less
6.
than? 6. And then the next one, more than the heavy one.
2.
2. Okay. Then you can add them together. Now, those of them who are more sensitive with numbers, do you notice 2, 24, 23, 24, 23 is the same? 2 and 6. 6 and 2, 6 times 2 is the same, right? So these two combinations are actually the same probability. So there are some cases, right, where you see books or assessment book, right? Sometimes instead of them writing it 2 times, they put the whole thing 1 probability, they times 2. Okay, why is that so? Because the numbers over here is repeated, is exactly the same, just that they have a change in position. So if you really understood that, then you do the shortcut. If you don't understand, then you write down the long cut method. Okay, you all calculate the answer. Okay, wait. What's the answer? I got 1/23. Is it correct? Is it correct? 1/23. Nobody answer me. So sad. Okay. Nobody answer me. Okay, never mind. I talk to myself. Correct. Okay, very good. Next question. 3 members are chosen. Oh my God. 3 members are chosen. Okay, let me worry about my denominator first. 3 members are chosen. First one, 24 out of 24. Okay, I have something, whatever that you want me to choose later. After I pick up my first person, how many? What's the denominator I'm left with for the next one? After I pick up one person, left with how many people for the second time I choose?
23.
23. Then the last one, I pick a third time. Third time, how many people to choose from in total?
22.
22. Okay, now let me look at my case. So they say 3 members are chosen. I have 3 already. Okay, at least one. What do you mean by at least one? Headache. Every time I see this kind of question, will have headache. At least one of the member more than 69 kg. At least one more than 69. There are many possible cases, right? I can have 3 person all 69 or more, all heavy, 2 person all heavy, or only 1 person heavy and put at different position. Am I going to count all the different possible cases? This one will be very tiring, right? Do you all remember what is the short?
Take the whole.
Yes, there is a shortcut, correct? Yeah, we said something just now. Where's my something? At least. So what I do, instead of finding all the different cases, I take one whole, minus away the case that I don't want. Okay, I take one whole, minus away the case that I don't want. I want at least one of them to be heavy. That means I don't want the case. I'm going to do 1 minus the case where all of them are lighter than, all 3 of them are less than 69. Okay, this is more than 69. I take one whole minus away less than 69 kg and less than, I write the symbol, okay, less than equal to, okay, I write symbol. English words too long for me to write. Math symbol is nicer. Less than 69 and then less than equal to 69 and then less than equals to 69. So I take one whole minus this whole probability. Now let us find out what are the people who are less than 69 kg. This one more, then I do the opposite. Less than 69. Where is less than 69 kg? Alamak, where is 69? 69 is 69. Where? Let me count my units first. 1, 2, 66, 67, 68, 69. Two squares, right? So 69 is here. Okay, so 69, I will draw 69. And then this one. What number is this? 20. Is it 23? 23, right? Is it 23? 23. Okay, I have too many numbers over at this corner already, so I can't really see very clearly. I think it's 23. All right, so I want less than 69. They want the case more than, but I'm going to do the one the less than minus away. So let's take 69. There are 23 students in total. So less than 69 is this one. Less than. Okay, so got 23 of them. So I first start off to meet my category. There are 23 of them that satisfy what I want. After I pick out one of them, how many such members that is less than 69 kg left for me to choose? After I pick out one, I took out one. How many of it?
22.
After I take out the two of them, how many? And next, how many here?
20.
Is it 20? Are you sure? I have 23. I took out one, become 22. I take out one more, become 21. Okay, then I save all my other cases. Then this one will be my final answer. 1 minus 23 over 24, 22 over 23, 21 over 22. Answer 1 over 8. Have you gotten the concept? Okay, these two questions are usually the harder ones that is in section B at the bottom. Okay, so need to take note. So if you choose to do statistics, you must learn to do the probability for this question. Okay, usually they'll combine circle properties with the sine rule, cosine rule, and bearing questions. Okay, all right. If that is the case, you have no other questions, then I come to the end of my remedial for today. All right, then you have any other things, you can ask me again. All right. If that's the case, then bye-bye. Thank you for attending my lesson.
Bye bye.
Bye-bye.
Thank you.
Thank you. Bye. Yeah.